So what makes sunshine possible? You may think it is nuclear fusion, but actually for nuclear fusion to happen, the protons in the sun need to come very close together and overcome the electric repulsion between the uh, positive charges. You know that protons are positively charged, and for nuclear fusion to happen they need to come very close together, and so they need to overcome the repulsion force which is extremely high, and the normal protons which have the mean average velocities are incapable of doing that. So then how do they achieve nuclear fusion? The answer lies in the Maxwell distribution of velocities. So let me draw that distribution here for your reference. So on the y-axis we will plot the probability, the Boltzmann function of the velocity. It is just the inverse of the velocity, and I mean the units are inverse, so the unit will be second per meter. And on the x-axis we will plot the velocity. Of the molecules. So the plot will be something like this. So the average velocity will be somewhere around here, this value. So the majority of the molecules will have velocities less than the average value, less than or equal to. So only few molecules are able to have velocities which are more than twice the average value. Okay, it's because of this Maxwell-Boltzmann distribution. So if it were not for this Maxwell-Boltzmann distribution, we would have expected most of the molecules to have some velocity very close to the average velocity. Then they would never be able to achieve the nuclear fusion. Because of this Maxwell-Boltzmann distribution, at least few of the molecules have velocities more than twice the average value, and so nuclear fusion becomes possible in the sun, and so the sun is able to shine, and life is also sustained on this planet.